Hi, now it is part 2 of section 5.1, the distance problem. We'll deal with distance problems. However, it is a part of finite summation approximation. Okay, here, once the velocity is constant, then distance traveled is the velocity times the time. But once the velocity is not constant, then you cannot get the distance simply. So here, we'll consider this example. The following table, this table, shows the velocity of model train engine moving along a track of 10 seconds. We want to estimate the distance traveled by the engine using 10 subintervals of length 1. Now using left-hand point, right-hand point, and midpoints, assuming that the velocity varies locally, linearly. Okay, here, now, once we try to get distance, now distance here left and by using left-hand point, then for this interval, we are using here, now the interval length is 1, but now velocity is 0. And for second subinterval, now the interval length is 1, but left endpoint value is 30, and so on. So that at the last moment here, now interval length is 1, now left endpoint value is 15. Okay, so that's the quantity. And if we try to get distance along with the right end point value, then in the beginning, the interval length is 1, and here velocity is 30. For second subinterval, interval length is 1, right end point value is 56, and so on. So that at the last moment, interval length is 1, and right end point value is 12. Okay, now if we try to get a midpoint value, assuming that the velocity varies locally linearly, so here midpoint value. Now again, for the first subinterval is interval length is 1, and mid value, assuming linearly varying, then the average value of that one will be 15. And for second subinterval, now average value will be here 43. Okay. Now here at last moment, here average value will be here 13.5. So you can sum these values, then they are answers. Okay, here we have the velocity values, and dt is 1, and here velocity left is just using from here to there, and velocity right is from here to there, to end, and average them is here now velocity midpoint. And if we sum them and times dt, of course dt is 1, and that will be distance along with the left hand point, right hand point, midpoint. Here we can print out, then the values are given here. That is distance traveled by using left hand point, using right hand point, and using midpoint. Okay, now we'll go to another problem. An object is dropped straight down from a helicopter. The object falls faster and faster because of the gravity. but the acceleration decreases over time because of air resistance. And now the acceleration is measured in foot per second squared and recorded every second after drop for 5 seconds, as shown in this table. Now, in the beginning, the acceleration will be 32 feet per second squared, and without air resistance, the gravity acceleration is given in this form. Because of air resistance, now acceleration becomes smaller. However, the velocity becomes faster for the object. Okay, these are recorded for 5 seconds. Okay, here, part A, find an upper estimate for the speed when t is 5. Okay, that is now upper estimation for velocity for given here acceleration. Now, for this subinterval between 0 and 1, now from in the beginning, the velocity will be 0 because it is fully falling down. Now, the among these two values, the recorded moment of 0, moment of 1, now the larger value must be chosen for upper estimation, so 32. Now, in this subinterval, and you have to choose large value, so that is 1941. So if you add to this one, then that is now 51.41. Now, for this subinterval, now this is a larger value, so you have to add to this one to get the upper velocity. So that is the same as 63 and 1A, and so on. So that if you fill out up to that one, that is the answer here now. How about lower estimate for the velocity? Okay. Now, for the first subinterval, here, the velocity is in the beginning here, at the end of the first interval, the velocity is here. So you have to choose a smaller one, which is 1941. So we put here now. Now, for the second subinterval, now lower estimate must be along with now lower value. So add them. It's the same as now. Okay, that is 31.1A, and so on. So that if you reach at here, then that is the answer. Now, how about C here? Find an upper estimate for the distance fallen when t equals 3. Okay, to get that, here, now the distance is just summed by velocity and time, then that is distance. So that upper estimate means you have to use upper velocity. So that for this first subinterval, now the upper value of velocity here 32. Okay, now for here, now in second subinterval, and the upper velocity is that value, so you have to add this value here in 32, so that is now 83, right? 83 and 41. Now, upper estimate for this third interval will be, now you have to add this upper one. So that is 146 and now 59. Okay, in this way, you can get it. Here, by using computer algorithm, we can check that. These are accelerations measured in from 0 time is 0, 1, 2, 3, 4, 5. Now here we are opening here velocity upper, velocity lower, and distance u upper. And for that, now in 0 initialized, and then from 2 to n, we are, for instance, upper velocity, and previous one plus now acceleration between, and this interval and larger value will be added. For lower velocity, from acceleration, we are choosing smaller value between two of them and added them. After that, now here for upper distance traveled is from earlier position, we're adding here now upper velocity and maximum one, larger one, and added. Of course, over there we ignore that the time interval is 1. For instance, delta t equal 1, then you can multiply here delta t and every over there delta t in fact. But we ignored that. Right? Okay. Now we print out, and here you can see that this is what you have to answer. This one, that one. Okay. This one, that one for part B. For part C, it is asking this value. So we found the right value over there. Okay. Now, here in this subsection, we try to consider average value of a non-negative continuous function. Okay. Now, here, we want to find, for example, if there are some discrete points and then discrete values, then average can be found quite easily. However, once it is not really the constant value, then sometimes the average value is not easy. For example, here now, average value of a function over an interval is not easy to compute. In this case, if it is constant, then quite easily you can get average value and is constant. But now, for this function, general function, the average value can be defined in this way. Average of f and times the interval length is the same as area under the graph of f over a and b. So that eventually the rectangle, if you consider here now rectangle, the rectangle area is the same as now this area under the curve. In this way, you try to find the average height. That average height is the average value. That is the definition. We try to get that way so that eventually average value of f is the same as 1 over b minus a, and now the area, okay, the area under the graph here. Okay. Okay. Let's try to get here average value. Now let fx is given 1 over x, defined on 1 to 9. We have to use a finite sum to estimate the average value of f on the given interval by partitioning the interval into 4 subintervals and of equal length and evaluating f at the subinterval midpoints. Okay, let's try to visualize the situation, the condition the problem is saying. Now, f of x is 1 over x, like that. Okay, so that this y equal 1 over x. Now from 1 to 9, we have to get 4 subintervals. Now we have to use here midpoint value. Of course, that point and that point, midpoint, that one, that is 2 and 4, 6, and 8. We have to use that midpoint value, and rectangle must be gotten in this way. And here, rectangle must be gotten here on the height here, and again here, and now again here, like that. So the summation of these 4 rectangle areas will be the approximation. Okay, so for each subinterval, so that approximation is given in this way. Average value of equals same as 1 over interval length is A. Now we try to get area. Okay, that is. Now for each one, the interval length is 2 times now at 2, so that is 1 over 2, because the function is 1 over x at interval length of 2, and at 4, 1 over 4, and plus the interval length 2 and 1 over 6, and plus the interval length is 2 and 1 over 8. Okay. If you are, okay, so that is now 1 over 8, and 2 will come out, and then here, okay, now 1 over 2 plus 1 over 4 plus 1 over 6 plus 1 over 8. Okay. If you practically add them, then you reach this quantity, so that eventually average value will be around 0.26. If you try to get true average value, then the quantity is this one. So even by using 4 subintervals, you can get really good approximation. Okay. Okay, this is the end of the section. Thank you.